Hello friends, I am Pramod Gorad. Welcome to my channel Mindset IT Practical.
So let's start with the palindrome number. Palindrome number is a number that is based on the reverse of a number. For example, if you take a number as 1, 2, 3 and reverse of this number is 3, 2, 1. So we have to show that the reverse of number and the previous enter number is equivalent. So in that case 1, 2, 3 is not a palindrome. Take one another example 1, 2, 1. The reverse of the number is again 1, 2, 1. So in this example a 1 to 1, that is 121, is a palindrome number. So let's take how to find the reverse number that we had discussed in our previous video. So let's take it to example 123. The reverse of his number is 3 to 1. So let's start with a division by a number 10. If you divide a number by 10, we get a division as a 12 and remainder as a 3. So we have to look into this 3. So we have to store somewhere. Okay. So we are going to create a parameter called as a value of n, value of sum, and the value of suppose reverse. Now for this we have to store this value. So here is the r is a remainder. So from previous slide we get a 3 as a remainder, that we have to put up in r. We get a 3. Now that will be get using a formula r is equal to n modulo 10. A modulo is indicate remainder for the given number. Now let's for a sum. Sum is initially as a 0, so that after multiplying with a 10 and adding the remainder we will get actual value. So let's start with calculation of a sum. So 0 into 10 is 0 plus r is 3. Now n is reassigned with the division method in floor division 10. So we get 123 as per our previous slide. The 12 is our new value for n. So we can write 12 over here. Repeat the steps until you will get a 0 in your value of n. Now the value of n is 12. The 12 modulo 10. 12 modulo 10 we get division by 10 we get 1, remainder is 2. So use in your statement and write New value of r is 2. New value for n is 1. New value for sum. Now sum has a 3. So 3 into 10 is 30. 30 plus 2 is 32. Still we get 1 in our n. So we can proceed for further iteration that will be reduced to a 0. So 1 divided by 10 we get 0, 0, remainder as a 1. So add into the table, remainder is a 1, sum is 0, sorry n is 0, and sum will be 32 into 10, that is 320, plus 1, that is 321. Now use this value to compare with our original value, that is 123. Hence we get to know that 123 is not equal to 321. Now we can implement in program. Let's start with the program. So we have to check the number entered by user is palindrome or not. To take as a number from the user, we use a int, that is typecasting, taking the input method entered by the user. Then we have to initialize sum 1 equal to 0 and store the original value into a temp variable. Now we find the sum of each digit as per discussion in the previous. For checking with value of number is not equal to 0. That means while loop is proceed until your number become a 0. For this, remainder equal to number modulo 10. In our previous discussion, we use r as a remainder. Then sum1 equal to sum1 into 10 plus remainder. Number equal to number floor division by 10. Compare with the original value. That means we have to use a conditional statement so that your previously value, that is temporary variable, is compared with the new value, that is sum1, and we get the result. If it is matches, true condition will be represent temp is a palindrome, else temp is not a palindrome. Save the program with a palindrome underscore number and run. Enter the number 123. 123 is not a palindrome. Rerun the program using a shortcut key F5. Enter 121. So 121 is a palindrome. Recheck for another example. For example, 3223. 3223 is a palindrome. So this is all about your palindrome. Now come to the next example, Armstrong number. The Armstrong number will be a number, for example 123. We have to cube of each digit and sum it. After doing a summation, we will have to get a 123. If it is the same number, we call as a Armstrong number. If we want to get this number, we call as this is not an Armstrong number. So let's see example. If you are doing 123, reverse of this number is 321. That means as we discussed in the previous, we required each digit individually, 3, 2, 1, and doing the operation as a cube of individual digit. That is 3 cube, 2 cube, 1 cube, and we have to do the addition. 3 cube is 27, 2 cube is 8, 1 cube is 1. the summation of is 36. As we get 123 is not equal to 36. Hence, this is not an Armstrong number. Similarly, for another number, 153. Again, segregate the number individually and take the cube of this number. 3 cube, 5 cube, 1 cube. Do the addition of this number, you will get 27 plus 125 plus 1. The number is 153. So here 153 is our Armstrong number. So using the previous, so have a look in onto a program, check enter number is Armstrong number or not. So we have to take a input from the user. For this we take a number equal to int of input, enter the number. Now initialize the sum and temporary variable for the original values. Sum equal to 0, temp equal to number. Now find the cube of sum of cube of each digit using the following operations. While loop to check the number is not equal to 0. Remainder equal to number modulo 10. Sum equal to sum plus remainder. Star star operator is power of that particular variable, that is exponent. Number equal to number floor division 10. Now display the result. For this we use a conditional statement to check the temporary number is compared with a new value, that is sum. Now print the statement temp is a Armstrong number if it is satisfied the condition, else temp is not a Armstrong number if does not satisfy the condition. Now run the program using a F5 keyword. Enter a number, that is 123. 123 is not a Armstrong number. Rerun the program. Enter 153. 153 is an Armstrong number. Now take one example, 370. Again 370 is an Armstrong number. So this is how we are finding out Armstrong number and the palindrome number. Thank you for watching. Keep learning.